Hello, I am Peter, and I will be guiding you through this module on different mathematical tools regularly used in financial analysis. In this video, I want to focus on the steps necessary to calculate the standard deviation when evaluating an exhaustive series of scenarios, each with a probability of occurring in the future. For example, if we pay attention to a publicly traded company, we might estimate the probability that it will exceed the earnings predicted by analysts, that it will at least meet this expectation, or that it will fail to reach these expected earnings. If the firm exceeds market expectations, the market may respond favorably, and we could estimate the return we would get if we own shares in that company. On the other hand, if the firm fails to meet market expectations, the market may respond negatively, and we could estimate the loss we would incur if we own shares in that company. Let's work step by step. Let's get started. In this case, as you can see in column A and column B, we have three scenarios. The firm could announce earnings below market expectations with a 30% probability. Alternatively, it could meet exactly the market expectations with a 25% probability. Finally, the firm could exceed market expectations with a 45% probability. If you notice, the sum of the probabilities is 100%, as these three scenarios cover all possible outcomes. In other words, this is an exhaustive list of scenarios with their respective probabilities. Let's review the steps necessary to calculate the standard deviation in this case of probabilistic scenarios. First, we calculate the expected return for this firm. In this case, statistically, the expected return is the average of the returns from each scenario weighted, or in other words, multiplied by its respective probability of occurring. The expected return in this context is 1.84%, and as you can see, it is not the same as the arithmetic mean. Don't let this confuse you. First point. The market has predicted that this firm will achieve an earnings per share value which is not mentioned in this problem. What we do know is that there is a 25% chance the firm will announce exactly this earnings value predicted by analysts, whatever it may be. In this case, if you own a share, it is estimated that the market will respond favorably and your share price will increase by 1%. Second point. We recognize that there is a 30% chance that, on the contrary, the firm will fail to meet the earnings predicted by analysts. In this case, if you own a share, it is estimated that its price will drop by 2.2%. However, you could get lucky, and if the firm announces that it has exceeded the predicted earnings, your share could increase in price by 5%. In this context, when we talk about expected return, what we do is assign each possible return of minus 2.2%, 1%, or 5% a weight equivalent to its probability of occurring. In other words, we weight them based on their probability and then sum the weighted values. This gives us 1.84%, which is what we call the expected return, or statistically, this corresponds to the expectation of the stock's return, taking into account that the firm's final earnings could fall within any of these three ranges. Second step, we calculate the deviation or difference of each scenario's return compared to the expected return we calculated in the previous step. For example, if we take the second scenario, where the firm achieved exactly the earnings the market predicted, the deviation from the expected return is minus 0.84%. In this case, the deviation is negative, meaning that the 1% return is lower than the expected return of 1.84%. The third step is to square each of the calculated deviations and multiply it by the probability of its respective scenario. We need to do this for each of the evaluated scenarios. Finally, when working with historical data, the last step was to calculate the average. However, by weighting or multiplying by probabilities, we have already done part of the averaging exercise. In this case, all that's left to do is sum the values in column E, and we're done. In cell E6, we see the variance value of 0.000957. Remember, the standard deviation is the square root, which we calculate in cell E7, with a value of 3.093%. Excellent work. Don't get discouraged if at some point some of these formulas seem confusing. With practice, they will become quite simple. Let's stay in touch.